So parametrizations of a line, and this is a theorem. So the line through the point A comma B, well, it's just a point of slope M is parameterized as x equal to a plus r of t, and y is equal to b plus s of t, for t is from negative infinity to positive infinity, because the line usually you don't have any restrictions. The domain of a line usually it's just all real numbers, right? Where t is between negative infinity and positive infinity. For any r and s such that the slope is equal to s over r, given that r has to be different from 0. Right. So let's try to parameterize this. Right. So let's do example here. So the equations of the line, you have y minus b equal to m times x minus a. We know this is the point slope form. The equation of a line. And in the theorem, it's given that the slope is equal to s over r. Right? So you replace, given that m is s over r, then you have y minus b equal to s over r times x over a. Now, if you divided both sides for s, we get y minus b over s equal to x minus a over r. Right, so this equation, right, the left-hand side equal to the right-hand side, and we can relate this two component by the third item, and we let this equal to t, this the parameter t. Right? And from here, you instead of one equations, now you have two equations, right? You have y minus b over s equal to t, which implies that y minus b equal to s times t, or y is equal to b plus s of t. Okay, so this is just one part of the parametric equations of the line. The second part is x minus a over r equal to t. And from here, you can solve for x in terms of t. You get x minus a equal to r times t, and x is equal to a plus r of t. Therefore, the parametric equations of the line y minus b equal to m times x minus a is so x equal to a plus r of t, and y equal to b plus s of t, given that m is s over r, for r is different from 0. This is a very specific way to parameterize this line, right? As I mentioned, there's infinitely many ways to parameterize this. And another way to parameterize this, very straightforward, very simple, is that you let x equal to t and y equal to whatever, right? So what I mean by that, right? So given the curve, this is a sine note, y minus b equal to m times x minus a, right? You can let x equal to t, right? And then y is equal to m times t minus a plus b. This is still a parametric equations of a line, right? Because again, the idea of parametric equation is you relate two variables by the third common item. And we just did, right? We relate x and y together by the third item, which is t in this case. With some other very simple functions that we can try, for example, parabola, right? So y equal to x squared. If you want, you can parameterize this by letting x equal to t, and therefore y is equal to t squared. This is parametric equations. So given the curve y equal to f of x, you can parameterize using the parameter t, right? Now, if they give you some parametric equations and they want to know what is the form of y equal to f of x looks like, this is the reverse process, and the reverse process is called the eliminating the parameter process. Right? So this is the next example. So this example is to eliminating the parameter. So given x equal to a plus r of t and y equal to b plus s of t, find the equations of the form y equal to f of x from the parametric equations. So you have to identify what is the parameter from the parametric equations, right? So in this case, the equation x equal to a plus r of t and y equal to b plus s of t has a common item, which is t, right? So after identifying the common parameter, you eliminate or you solve for t and then substitute whatever you have for t into the other equations. So what do I mean by that? So first I pick the equation x equal to a plus r of t, and I solve for t, okay? So that means x minus a is equal to r of t. Now divided both sides for r, you have x minus a over r equal to t, right? So you just eliminate t, or you solve for t. Now t is equal to x minus a over r. Next, you substitute t into y equal to b plus s of t. We obtain, right, so y equal to b plus s times x minus a over r. So this gives me b plus s over r times x minus a. We let m equal to s over r, and we get m e times x minus a plus b. And it could be done with the problem, right? So this is the form y equal to f of x. So given the parametric equations, we just turn the parametric equations into the equation of the form y equal to f of x. Next example, eliminate the parameter t given the equations x equal to 3 minus 4t and y equal to 2 minus 3t. Okay. Very similar to the previous example, you pick either the equations, solve for t, whatever you get for t, substitute t back into the other equations, the remaining equations, right? And again, the common item between x and y here is the parameter t. So let me do this one. So from x equal to 3 minus 4t, we can solve for t. Right? We get x minus 3 equal to negative 4t. Now divided both sides for negative 4. You get x minus 3 over negative 4 equal to t. Then you substitute t into the remaining equations, or equations y equal to 2 minus 3t. We get y equal to 2 minus 3 times x minus 3 over negative 4. And we get, simplifying a little bit, you get 2 plus 3 over 4 times x minus 3. We're done with that. All right, more example. So this example is a little bit different compared to the last two. Eliminate the parameter t given the equations x equal to 1 minus 2t and y equal to 1/2 t minus 1, where t is restricted between -2 and 4. The difference between the example here is that for this example, you have some restriction on t, right? So that means you have to find the domain of the curve that you get, right? Y equal to f of x. After you get y equal to f of x, you have to define the domain, okay? Okay, so let me note quick here. We need to find the domain later. Okay, but the process of eliminating the parameter t is very similar to the previous example. It's just that at the end, after you get y equal to f of x, you have to define the domain of the curve, right? That means you have to find the restrictions for the value of x. Okay. So here, so from x equal to 1 minus 2t, you get x minus 1 equal to -2t. Now divided both sides for -2, you get t equal to x minus 1 over -2. Then you substitute t into the remaining equations, which is y equal to 1/2 t minus 1. We get y equal to 1/2 times x minus 1 over -2 minus 1, or y is equal to -1/4 times x minus 1 minus 1. You can certainly simplify this further if you like. You don't have to, but if you like, you can. This gives you y equal to -1/4 x minus 3/4. All right. So given the parametric equations, you can rewrite the equations in terms of the equations y equal to f of x. Now, and we mentioned that since there are some restrictions for t, you need to find some restrictions for x as well. When t is between -2 and 4, what is the value of x? And you can solve the value of x using these equations, right? So to find the restrictions of x, we substitute x minus 1 over -2 equal to t into the inequality. We get, right, so -2 is less than or equal to x minus 1 over -2, less than or equal to 4. Now to get x by itself, right? So you multiply everything for -2. Right? So that means I'm going to do -2 here, -2 here, and -2 here. And when you multiply a negative number for inequality, all the directions of the sign will change. Right? So that means you get -8 less than or equal to x minus 1 less than or equal to +4. Now to get x, you add 1 for every term in the equality. So you get -7 less than or equal to x less than or equal to 5. Right, so x value has to be restricted between -7 and 5. One more example, we can move on with lecture 1. eliminate the parameter t given the equations x equal to 2 times cosine of t and y equal to 3 times sine of t. If you notice this looks very similar to the general form of an ellipse, right? So we talk about the parameterized or parametric equations of an ellipse earlier, right here. Right? So x is equal to a times cosine of t, and y is equal to b times sine of t. And you can rewrite these parametric equations into this form, right? Okay, so how could you do that? So for ellipse and circle, the technique is a little bit different, right? You have to use some trigonometric identity, right? So from here, you have, instead of x equal to 2 times cosine of t, you write cosine of t equal to x over 2. And instead of y equal to 3 times sine of t, you write sine of t equal to y over 3. Okay. And then with the equations that we just got, I'm gonna square both sides of the equations. So this gives me cosine squared of t equal to x over 2 squared. And sine squared of t is equal to y over 3 squared. Then I will add these two equations together. So cosine squared of t plus sine squared of t equal to x over 2 squared plus y over 3 squared. And this is the trigonometry identity. This leads us to 1. Well, you get 1 equal to x over 2 squared plus y over 3 squared.